In this video, we'll talk about continuity of piecewise defined functions. Let's do this with an example. In this problem, we have to find all points of discontinuity for this function. The function is defined as fx is equal to 2x plus 3 when x is less than equal to 2 and 2x minus 3 when x is greater than 2. Pause the video, give this a shot. Alright, so the function is defined in two parts. That's why we call it piecewise defined function. The first part is 2x plus 3. This is for x less than equal to 2. And the second part is 2x minus 3. That's for x greater than 2. Now both these parts independently are polynomial functions. We have 2x plus 3 and 2x minus 3. Polynomial functions are continuous throughout. This means that for all values less than 2 and for all values greater than 2, the function is continuous throughout. So all we need to do is check for continuity at x equals to 2, because this is where the definition is changing. So let's do that. We'll find the left hand limit using this one and right hand limit using this definition. So the left hand limit at x equals to 2, this is x approaching 2 minus, x tends to 2 minus fx, and right hand limit is x tends to 2 plus fx. So let's figure this out. For this one, left hand limit, we'll use fx equals to 2x plus 3. And for this one, right hand limit, we'll use fx is equal to 2x minus 3. For left hand limit, we have 2 times 2 plus 3. And for right hand limit, we have 2 times 2 minus 3. So this is 4 plus 3, 7. And this is 4 minus 3, that's 1. So left hand limit is not equal to right hand limit. So these two are not same. This means that the limit does not exist, which means that the function is not continuous. So the function is not continuous at x equals to 2. Let's try one more. Fx is equal to this. So this is divided into 3 parts. The first part is for x less than equal to minus 3. The definition is mod x plus 3. This next part is from minus 3 to 3. The definition is minus 2x. And the third part is x greater than equal to 3. The definition here is 6x plus 2. So pause the video, figure out for which points do we need to check continuity, and then check the continuity. Pause the video. Okay, so let's try this together. Polynomial functions are continuous throughout. But mod x, which means mod function, this is also continuous throughout. So we don't need to check for less than minus 3. We don't need to check between minus 3 and 3. And we don't need to check for x greater than 3. Which means we'll check at points where the definition is changing. We'll check at minus 3 and we'll check at 3. So let's do that. For minus 3, left hand limit is x tends to minus 3 minus fx. That's equal to x tends to minus 3 minus mod x plus 3. Because when x is less than minus 3, we use this definition, mod x plus 3. We can plug in minus 3 here. We have minus 3 mod plus 3. So this is 3 and 3. This is 6. So left hand limit at x equals to minus 3 is 6. What about the right hand limit? Right hand limit is x tends to minus 3 plus fx. So we'll use this definition, minus 2x. So minus 2 times minus 3, we can plug in the value. Minus 2 times minus 3, that's minus minus plus 2 times 3, 6. So the limit exists. This means whether we approach minus 3 from the left side or we approach it from the right side, the function is approaching 6. It's approaching the same thing. What about the value at minus 3? Well, for that, we'll use this definition because this is saying x is less than or equal to minus 3. So for minus 3, we'll use this one, but we have used this one and figured out that the value is 6. This means the value of the function at minus 3 is 6. The left hand limit is 6 and the right hand limit is 6. All three are the same, so we can say that the function is continuous at x equals to minus 3. Let's check for the next point, x equals to 3. Left hand limit, x tends to 3 minus. So we'll use this definition, minus 2x, because we are less than 3. So minus 2x means minus 2 times 3, which means minus 6. What about the right hand limit? For that, we'll use this definition, 6x plus 2. So x tends to 3 plus fx. This is limit x tends to 3 plus 6x plus 2. We can plug 3 here. 6 times 3 is 18 plus 2 is 20. So this is very different. minus 6 is not the same as 20, which means the limit does not exist, which means the function is not continuous at x equals to 3. So this is how we check limits and continuity for piecewise defined functions. Let's solve one more problem. Fx is equal to x by mod x when x is less than 0 and minus 1 for x greater than or equal to 0. Pause the video, check for continuity of this function. Okay, let's do this together. We'll check at this point where the definition is changing. Let's check at x equals to 0. So the left hand limit will be x tends to 0 minus fx, and we'll use this definition because when x is less than 0, the function is taking this value. So x by mod x when x tends to 0 minus. So we'll change the limit and write it like this. Limit h tends to 0, h is a very small positive quantity. So this is 0 minus h because we're approaching 0 from the left hand side. So we'll replace x by 0 minus h. We'll do the same in the denominator. So 0 minus h by mod of 0 minus h. This is minus h by h because mod gives you the positive value. So this will be minus 1 because h cancels out. And this is a constant. So the value is minus 1. So the left hand limit of this function at 0 is minus 1. What about the right hand limit? Right hand limit is x approaching 0 plus fx, but the entire value is minus 1. Anything that you take that's more than 0, in fact, even at 0, the value is minus 1. So this is minus 1, which means it stays the same. The value of this function for x greater than 0 is minus 1. So that's our right hand limit. What about the value at 0? Well, the value at 0 is also minus 1. So that's minus 1. All three values are the same. That's minus 1, which means the function is continuous at x equals to 0. All right. What about other points? What about values that are not 0? What about all the positive values? Well, for all the positive values, the function is taking the same value, that's minus 1, which means it's a constant function. It does not break. The function is continuous for all values of x that are greater than 0. So it's continuous at 0. It's continuous for positive values. What about negative values? Is it continuous for x less than 0? Well, yes, it's continuous for x less than 0 as well. Let's see how. Limit x tends to c fx. Here c is any number that's negative. Let's see what the limit is. So that's limit x tends to c x by mod x. Now if you try putting a negative number here, you'll get a negative value in the numerator and the same value but with a positive sign in the denominator. If you put in minus 3, you'll get minus 3 by 3. Whatever you put, you'll get a negative sign on top and a positive sign at the bottom. So minus by plus, the value will be minus 1. So for any value that's negative, the limit will be minus 1. That's going to be a fixed value that's going to be minus 1, which means that the function is continuous for all values that are negative. So it's continuous for positive values, for negative values, and at 0. This means this function, it looks a little messy, but this function is continuous throughout.